Hello everyone, welcome back to CMME Made Easy, and I hope you all are doing very well. Before we begin, let me remind my dear students that the contents of this channel are only to supplement your knowledge, not to replace the regular online and offline classes in your institution. So please attend your classes and do not miss them. Also, if you like our contents, please subscribe to our YouTube channel, like the videos and share these videos with your friends, with your batchmates, with your juniors. Also, if you are a teacher, then with your students. Please follow our Facebook page and the link will be given in the description. If you remember, we finished our last video talking about how the prevalence of a disease in a given community can alter the predictive value of a test that can be a diagnostic test or a screening test. This was the last slide of that video and it shows the relation between the prevalence of a disease and the predictive values of a test. So as you can see in this table, when the prevalence of disease is high, the positive predictive value is high but the negative predictive value is low. But when the prevalence is low, the scenario is reversed. In low prevalence, the positive predictive value is low but the negative predictive value is high. Today in this video we shall discuss this thing with an example so that you understand it quite easily. So here we have taken the example of HIV infection and the test, the diagnostic test you can say, or maybe the screening test, whatever that we shall be talking about is ELISA. Now the sensitivity of ELISA in diagnosing HIV is 99%. So you can see it is quite high. Specificity of ELISA in diagnosing HIV infection is 90%. So it is also high, very high, but it is not as high as the sensitivity. So anyway, we have sensitivity of 99% and specificity of 90%. Now we are going to compare two different population of equal size. That means number of people living in each population is same. Here we have taken an amount of 20,000 people with different prevalence of HIV. So these two populations have two different prevalences of HIV. The first one is 5%. So in the first population we have 5% of people suffering from HIV, and in the second population the prevalence is 25%. That means in the second population 25% of the people are suffering from HIV. So these are kind of arbitrary numbers just taken for the sake of explaining this phenomena, and then we are going to calculate the positive predictive value and the negative predictive value of ELISA in diagnosing HIV infection. So we have the first population where there are 20,000 people as I mentioned earlier, and also the second population or population number 2 with 20,000 people. So both this population have the same number of people in them. This is followed by prevalence of the disease. In the first population, the prevalence is 5%, we know, and in the second population, the prevalence is higher, that is 25%. In the first population, since we are going to apply the ELISA test, the sensitivity of the test is 99%, specificity is 90%, which we discussed in the previous slide. And also, in the second population, the same ELISA test will be having 99% of sensitivity and 90% of specificity. This is very important that we understand that in any scenario, whenever a test is applied in any situation, in any population, irrespective of the prevalence of the disease in that population, the sensitivity and specificity are always fixed. So remember this, the sensitivity and specificity do not depend or vary according to the prevalence of the disease or any other situation. So these are fixed values. So that is why in both population, when ELISA is applied, it has sensitivity of 99% and specificity of 90%. So after applying this test, we shall try to find out the positive predictive value and negative predictive value in the population 1, also the positive and negative predictive values in the population 2. So as you can see from this slide, since we are comparing between two populations, both having 20,000 people and having the same test with same sensitivity and specificity, the only difference between these two populations are the prevalence of HIV. One having 5% prevalence, another having 25% prevalence. And then we are going to see if this difference in prevalence actually causes difference in positive and negative predictive values when this test is applied in these two populations. So first we are going to talk about population 1. The number of people living in population 1 is 20,000. The prevalence of HIV is 5%. So of all the people, 5% of them will be having HIV. So the total number of people with HIV is 5% of 20,000 people, that is around 1,000 people. And rest of the people will be free of HIV. So the total number of people without HIV is 20,000 minus 1,000, that is 19,000. So we have the first part of our 22 table. Here in the column we have HIV infection either present or absent. So present, that means people suffering from HIV are 1,000, and absent, that means people without HIV are 19,000. So we got these values from these calculations. We still do not have any idea about the test results, right? So remember these two parts. Next comes the sensitivity of ELISA, which is 99%. You remember what is sensitivity? Sensitivity is the ability of a test to detect the disease among those who are suffering from the disease. So that means of all the people who are suffering from the disease, how many of them will test positive? We have 1,000 people suffering from the disease. If the sensitivity is 99%, that means 99% of those 1,000 people will be tested positive by ELISA. So the people with HIV giving positive result is, that is the true positive, because they are suffering from the disease, because they are people with HIV and they are giving positive results. So hence they are true positive. So that is 99% of 1000, which is 990 or 990. Similarly, specificity of ELISA is 90%. This is also given. That means out of all people who are not suffering from HIV, how many of them will test negative? So the people without HIV giving negative result, that is true negative, because they are not suffering from the disease and they have also given negative test result. So that is why they are negative, which is true. So this is true negative. So that means 90% of 19,000 people, these 19,000 people were the people who did not have any infection. So that is around 17,100. So now we have two more values in the table. We have the true positive value, that is 990. You can see they are the people who have the disease and also tested positive. And then we have the true negative value, that is the people who do not have the disease and also tested negative, right? Now we have the column total as 1,000 and 19,000, and we have two different values. So from this we can also complete our table here. So we now know, so this value should be 10. So this is disease positive but tested negative. So this is basically false negative. What about this part? This is they do not have any infection but they tested positive. So this is false positive. And of course this has to be 1900, because this value plus this value has to be 19,000. Similarly 990 plus this value has to be 1000. So right now we have true positive of 990, false positive of 1900, true negative of 17,100, I'm sorry, and false negative of 10. Now since we have all this data about true positive, false positive, true negative and false negative, we can right now calculate the positive and negative predictive value. So the positive predictive value is true positive divided by true positive plus false positive. Now I am not going to discuss this formula. It was discussed in the previous video and I am sure you already know by now. So this calculation comes out to be 0.3426, which is about 34.26%. So the positive predictive value of ELISA in first population is 34.26%. Similarly, negative predictive value is given by true negative divided by true negative plus false negative, and the value comes out to be 99.94%, right? So 0.9994, if you multiply it with 100, then we get the percentage value, which is 99.94%. So these are the positive predictive value and negative predictive value of ELISA when applied in population 1, where the prevalence of HIV is 5%. Now we move on to the population 2. Population 2 also has 20,000 people in it, but the prevalence of HIV is 25%. So similarly, we can know the number of people with HIV infection in this population is 25% of 20,000, that is 5,000 people. And the people without HIV should be the rest of the people, that is 20,000 minus 5,000, that is 15,000 people. So again we have the first part of our table here. HIV infection present in 5,000 people and infection is absent in 15,000 people. Next we have the sensitivity of ELISA, that is 99%. Same as I mentioned earlier, the sensitivity and specificity do not change depending on the situation or even the prevalence of the disease. So here also we shall have 99% of sensitivity and 90% of specificity. Now the people with HIV giving positive result should be the 99% of all the people suffering from the disease. So disease was present in 5,000 people, 99% of them will show positive result, and hence that will be true positive. So the amount is 4950. So 4950 people will be the true positive. That means they will be suffering from the disease and also give the positive result. Specificity of ELISA is 90%. So the people without HIV giving negative result, that means they are true negative, is 90% of all the people who are not suffering from HIV, and HIV infection is absent in 15,000 people. So 90% of 15,000 is 13,500. So now we have the next part of the table. We can see the total number of people with infection is 5,000. Of them, true positive is 4,950, whereas people without infection is 15,000, and of them 13,500 people are true negative. So we have true positive and true negative value, and of course since we have the column total here and here and we have two values here, we can calculate the rest of the part. So the people with HIV infection but giving negative result, that means false negative, is 5,000 minus 4,950, that is 50. So 50 people are false negative. Similarly 15,000 people are false positive. Always remember these two values when added should give the column total, and these two values when given when added together should give the column total here. So right now we have the true positive value of 4,950, false positive value of 1,500, true negative of 13,500, and false negative of 50. Now again we can calculate the positive predictive value and the negative predictive value following the formula. So the formula for positive predictive value is true positive divided by true positive plus false positive, and this value turn out to be 0.7674 or 76.74%. Similarly, the negative predictive value, which is given by true negative divided by true negative plus false negative, the value is 0.9963, and it is basically 99.63%. So now we have the positive and negative predictive values of ELISA test when applied in the second population as 76.74% of PPV and 99.63% of NPV. Here in the next slide we have summarized the findings. So in population 1 and population 2 we have 20,000 people in each population. So as you can see they are similar, right? Prevalence of the disease varies. So 5% in population 1 whereas 25% in population 2. So the prevalence is higher in the second population. When the ELISA test was applied for both the population, the sensitivity was 99%. So 99% sensitivity in both population 1 and population 2, and also specificity was 90% in population 1 and also population 2. They do not vary. Next we got the positive and negative predictive values. So in population 1, positive predictive value was 34.26%, whereas in the population 2 the positive predictive value was 76.74%. So what do we see here? When the prevalence is low, that is 5% as compared to the 25%, positive predictive value is also low, 34.26% as compared to the 76.74%. So as you can see, this difference is quite prominent as the prevalence is also different here. In case of negative predictive value, the scenario is reversed as I mentioned earlier. When the prevalence is low, only 5%, the negative predictive value is 99.94%, right? But when the prevalence is high, that is 25%, the negative predictive value is 99.63%. Of course, these values are very close to each other. That is because the specificity is only 90%. Now 90% itself is quite high, but if you compare it with the sensitivity, which is 99%, I shall say the 90% is quite low as compared to 99%. If we had specificity at around 97, 98 or 98%, then the difference in negative predictive values in the two population would be more clear. Anyway, even though the difference is very small, but still you can find the difference, and you can see when the prevalence is low, that is only 5%, that negative predictive value is higher. Whereas when it is increased to 25%, the negative predictive value is low. So we can say when the prevalence of the disease increases, the positive predictive value is increased, but the negative predictive value is decreased. Whereas when the prevalence of the disease is low, the positive predictive value decreases, but the negative predictive value increases. So the prevalence of the disease has direct relationship, or direct relationship with positive predictive value, but inverse relation with negative predictive value. So I hope with this example it is quite clear how the prevalence of a disease can actually affect the positive and negative predictive values of any diagnostic test or screening test. So thank you. With this we conclude this short video, and if you like the video, please subscribe to our channel and share this video with your batchmates, friends, juniors. We also have our Facebook page that you can follow. The link is given in the description. Take care, and we shall see you in our next video.